Richter scale was invented in the 1930s to give some understanding to the magnitude of a quake as measured by seismographs, ground monitoring equipment that's often used in earthquake measurement. It's logarithmic, so every 1 point on the scale is a 10-fold increase. So a 3 to a 4 on the Richter scale is 10-fold more powerful, and 3 to a 5 is 100-fold. Or to put it another way, a 7 is 10,000 times more powerful than a 3 on the Richter scale. The U.S. Geological Survey says that there are 1.4 million quakes that register above 2 every year, and only 16 that get a 7 or higher. But even after I've explained it to you, do you actually know what the Richter scale means? What does that number mean? Because I don't know. The Richter scale is only concerned about the amount of energy released by that single quake, and doesn't tell us much about what that quake did. Maybe it was a deep quake or away from a populated area. Maybe the quake was under soft ground or in the middle of firm bedrock. All of that would change how that earthquake was experienced or how humans feel it. The Mercalli
When an earthquake hits, we're all pretty used to hearing about its magnitude. A 5.8 for the Virginia 2011 quake, a 7.0 for Haiti's devastating quake in 2010. But what exactly do those numbers mean? They represent the energy an earthquake releases, basically how powerful it is, and the numbers build exponentially. And that can be a hard thing to picture. That's why this animation is so handy. It shows just how big the difference is from one magnitude to the next. Each magnitude is basically 33 times more powerful than the last. That means a magnitude 7 earthquake is 33 times more powerful than a 6. So take a look at that 5.8 Virginia quake. It looked pretty small compared to those 6.9 quakes. But compared to that 7.7 Sumatra quake, it looks tiny. And it's all because of this exponential scale. It builds fast, by a factor of about 33 with every jump. So the difference between two magnitudes, between a magnitude 6 quake and a magnitude 8, is 33 times 33, or 1,089. Do the math, and a magnitude 9 earthquake, like Japan's catastrophic Tohoku quake in March 2011, is 35,937 times more powerful than a magnitude 6. Even though we've gotten really good at measuring earthquakes, it's still impossible to predict them. Scientists can't say when the next colossal earthquake will happen, but they do know.
The Earth is covered in tectonic plates that slowly move around its surface. Most of the time, we don't feel a thing. The places where they meet are called fault lines, and that's where most earthquakes happen. The edges of the faults are rough and sometimes get stuck together. There is then a build-up of energy as the plates continue trying to move, or come under pressure from other plates. When it becomes too great, the plates suddenly slip, releasing energy in seismic waves that shake the Earth as they move through it. Earthquakes are recorded by sensitive instruments and measured on the Richter scale. It's an exponential scale, which means every number up is a 10-fold increase in the size of the earthquake. Earthquakes that measure up to about 4, or with epicenters far below the Earth's surface, are barely felt. At 6, some buildings are generally damaged, depending on the quality of construction and how deep below the earthquake's origin occurs. Quakes close to the surface produce more damaging energy waves. But even earthquakes this size can be devastating. The one that struck Christchurch in New Zealand measured 6.3, but killed nearly 200 people. In the sevens, buildings can separate from their foundations. Underground pipes may be broken, and there will be visible cracks in the earth. A magnitude 7 earthquake caused the deaths of about 220,000 people when it struck Haiti in 2010. An earthquake measuring 9 or more on the Richter scale will leave almost total devastation, and the energy waves will be visible as they move through the earth. The earthquake behind the Boxing Day tsunami measured 9.1, and it was a magnitude 9 that devastated part of Japan in 2011.